All right, today we are pulling back the curtain on the single most important rulebook in the modern world. Seriously, we're talking about the TCP/IP Protocol Suite. I mean, just stop and think about that for a second. Your phone, my laptop, a server halfway across the planet, your smart fridge. How in the world do they all just connect and understand each other instantly? It really does feel like magic. But what's actually going on is way more interesting. You see, the answer is that they all agree to speak the same language. It's like a universal translator, but for machines. They all follow a very specific, shared set of rules, a protocol that governs every single thing they do online. And that set of rules is called the TCP IP Protocol Suite. It is, and I mean this literally, the backbone of the entire internet. It gets its name from two of its most famous protocols, TCP, that's the Transmission Control Protocol, and IP, the Internet Protocol. We'll get to them in a bit. Honestly, the easiest way to wrap your head around this whole thing is you just think of TCP/IP as the internet's official rulebook. Every single device, every app, from the biggest web server to the tiniest sensor, agrees to play by these rules. That's how data gets from point A to point B without getting lost. Now, you can imagine a rulebook for the entire internet would be, well, impossibly complicated, right? So to make it all manageable, the whole thing is broken down into a 4-layer model. Think of it like departments in a giant company. Each department has a very specific job, and they just focus on that one job. And here they are, the 4 layers, stacked from top to bottom. Up at the top, we have the application layer. That's where we hang out. Then you go down to the transport layer, then the internet layer, and all the way at the bottom, the foundation, is the link layer. Each one does its part of the job and then cleanly hands off the results to the layer below it. It's a beautiful system. So, what do you say we take a quick tour? Let's follow a piece of data, like an email you're sending, as it travels down through these layers on its way across the world. We're starting at the top, layer 4, the application layer. This is the part you actually see and touch. It's your web browser, your email app, your game. This layer is all about the protocols that those specific applications use to get the data ready to be sent. And there are some famous protocols living here. For instance, you've got DNS, the domain name system. That's basically the internet's giant address book. It turns a human-friendly name like google.com into a numbered address a computer can actually find. Then there's SMTP, the simple mail transfer protocol. That's the rulebook for sending an email. And FTP, the file transfer protocol, which handles, you guessed it, file transfers. Okay, so your email app is ready. It hands the data down to the next layer, the transport layer. Now, this layer's whole job is to set up a solid connection between the two devices and decide how the data is going to flow between them. And it has 2 very different ways of doing that. And the analogy for this is just perfect. On one hand, you have TCP. Think of TCP like sending certified mail. It's all about reliability. It numbers every packet, checks that they all arrive, and makes sure they're put back together in the right order. This is what you want for email or a web page, where every single bit of data has to be there. But on the other hand, you've got UDP. Think of UDP as sending a postcard. You just write it and send it. It's super fast, but there's no guarantee it'll get there. This is perfect for things like video streaming or online gaming, where speed is everything and losing one tiny packet here or there doesn't really matter. Okay, so our data is packaged up. Now it needs to be delivered. That's the job of the next layer down, the internet layer. If the transport layer is about packaging, the internet layer is the global postal service itself. Its job is all about addressing and routing. And the superstar of this layer is, of course, the Internet Protocol, or IP. This is the IP in TCP/IP. Its job is to stamp every single packet of data with a destination IP address, that unique number identifying every device online, and then it acts like a GPS, figuring out the best, most efficient route for that packet to travel across the entire internet. Finally, we hit the bottom, the link layer. This is where the digital ones and zeros of your data become actual physical signals. We're talking about the hardware, the Ethernet cables, the Wi-Fi radio waves, the pulses of light in a fiber optic cable that physically move the information from one point to the next. So we've seen all 4 layers, each one laser-focused on its own specific job. But the real genius here isn't what any single layer does. It's how they all work together. You know, there's this quote from the poet Emily Dickinson that people often bring up when talking about TCP/IP. I dwell in possibility. And it might sound a little strange for a tech topic, but it is so fitting, because this layered model is what creates the endless possibilities of the internet. So why is this so powerful?
Well, first, it takes a ridiculously huge problem and chops it up into four smaller solvable ones. Second, it standardizes everything, making sure a phone from one company can talk to a server from another. But this third one, this is the real game changer. It enables innovation. Think about a new technology like 5G. That's all happening at the bottom, at the link layer. Because of this model, engineers could invent and roll out 5G without having to change anything about how email works up at the application layer. You can innovate on one layer without breaking the others. It's absolutely brilliant. And of course, it's what allowed the internet to scale from just a few computers to the billions of devices we have today.
So the next time you send a text or watch a video, just remember what's happening beneath the surface. It's not magic at all. It's this beautiful four-layered system of cooperation, a simple rulebook that billions and billions of devices have all agreed to follow every single day. And that kind of leaves us with one final big question to think about. This model has served us incredibly well for decades. But as technology races forward, what rules will the next internet run on? What will its layers look like? Something to think about. Thanks for tuning in.